Hey there everybody, welcome back. I'm Chili and this is episode 11 of the HUGS series. Today, we're going to be building on what we started in the last episode. We created a kind of system to work with XAudio 2, and now we're going to build on top of that a sound effects system to make it sound all pretty and to link up with our game engine. We're also going to have to deal with a little bit with threading. Just some bullshit along the way. Threading, some bullshit with the Windows SDK, and other fun stuff like that. Let's take a look at the docket, shall we? All right, here we are. What's on the menu for today? First things first, we're going to talk about XAudio and the Win SDK and just general Microsoft bullshit. Because this is the bullshit that I had to deal with when I was making this code. So let's get up our program and let's see what we have to see. We were working in sound. Here's our history. I've added a whole bunch of different branches in here so that I can get at the code in various stages of completion. First thing we're going to work on is this branch called Win8. So if you want, you can create a branch here and follow along, or you can just watch me. There's probably nothing much to do in this part of the episode anyway, so you might as well just watch. Now, we're going to go to sound.h, and there we go. Okay, so you might have noticed in the last episode, or I think I've talked about it, but anyways, this is kind of weird. We're specifying an absolute path to an include file. Normally you don't do that, and the reason you don't do that is because if someone else tries to build your code and their SDK is in a different path or on a different drive, it's not going to build because it's not going to find the file. So, why are we doing this? Well, let me give you a short explanation via demonstration. So let's just build it with this. This will look in the Win SDK folder for XAudio 2. And it does exist in there, but when you build it, you get the error, oh, I'm sorry, when XAudio 2 is available only, this version is available only in Windows 8 or later. Go fuck yourself, thank you, fuck you. So, Microsoft wants you to buy more operating systems from them, even if you don't need them. Are you going to comply? I'm not gonna. So, what do you have to do? Well, you gotta do a bunch of bullshit. Now, first thing is first, I want to address that error that we actually got right there. Let me just build this again, so I'll show you. This error, originally I didn't get that error, and I didn't know what the fuck was going on. So I'm going to show you what happened to me. Now, what happened to me was, I didn't have this Chili Windows define in here. I didn't have defined Windows 32 WinNT 0601. This specifies, I think this specifies Windows 7. I think 060, fuck you. 060 fuck you. No, that's 0600 specifies 00000. No, it specifies the Vista. That's what the one that shall never be named, Vista. So I should probably target Vista just to be safe, but Jesus Christ, I mean, if you're using Vista, just use Windows 7. It's anyways. So yeah, I didn't have this to begin with. It's actually a good idea to specify your the minimum platform that you're targeting, but I don't know. You learn something new every day. So let's start with this. So if I don't specify this and build it, then it will try to build, but it won't find a symbol because in the Win SDK version of XAudio 2, you need a library. So what I'm going to do is I'm just going to copy and paste from off screen, and I'll put it down here, I guess. I don't know. It doesn't matter where it goes. It doesn't matter what your name is. We're going to go xaudio2.lib, and hopefully this works. Build. And now it's fine. It has found the implementation function or whatever it was looking for it, because it can link to this. And now it's going to build. So, okay, problem solved. Looks like we didn't need that absolute path anyways. System error, the program can't start because XAudio 2_8 is missing from your computer. Try getting a better version of Windows and giving us money. No. All right, so that's what you get. And that's what I got. And I was like, what the fuck? So I looked up some bullshit online and I figured out that Windows SDK doesn't support, or the XAudio in Windows SDK doesn't support Windows 7 or earlier. So, solution to that was as you seed doing this, and you've got to obviously install Windows SDK. Latest one is 2010. So you've got to install this, and then you've got to make sure that you use this specific include file, which is bullshit because now if someone downloads the source code, they might not be able to build it even if they have the SDK installed. Fucking bullshit. We'll go EU here, uncomment that. So it's just a good idea in general to define this. So I'm going to keep it. And instead of including now Windows everywhere, I include Chili Windows, which does this. There's other switches you can use to configure how Windows works in its headers and stuff. Like there's a lean and mean configuration where it just includes less bullshit, so it's a faster build. And there is a no min-max one, which doesn't define the min and max macros, which can actually fuck up your code because they're global and they just mess up your namespace. You take a big steaming dump on your namespace. So, I mean, I haven't done it yet, but I suppose sometime in the future I will get rid of the Windows min-max and use the one from the standard template library. There's a way to do it, but it's kind of fucking annoying. Anyways, that's neither here nor there. Last thing I want to tell you is even if you... where's my bullshit? Here it is. So even if you use the absolute path here, and you don't have to specify this, by the way. It works without it, but it's just a good idea. But even if you use this absolute path, that's not enough. What you've got to do is you've got to go into your properties, and in your... where is it? In your directories here, you've got to add your DirectX SDK directory \include. Otherwise, it'll find this file, but all of the includes that XAudio 2 depends on, it's not going to find them. So let's just try that out. Just for giggles and shits. We're going to get that out of there. Yeah, we'll just do it for active release. That's fine. Okay, apply. And then we'll build. And we'll get a whole shit ton of errors. XAudio 2 debug, undefined. It's all in XAudio 2. So obviously not good for calculators. Now, put this back in here. Oh, I just put it in twice. That's probably not what you want to do. Put it in once. And apply. Build. And Bob's your uncle. Everything's good. So that's the bullshit that I had to deal with. And it might seem simple to you, but I was like, what the fuck? Because all the information online, like old code and stuff like that, wasn't aware of the new Windows SDK. So it just said, you do this and you're fine. And I did it and I wasn't fine. Oh yeah, one more thing I'd like to add is that another solution that I'm actually thinking of is just go into this folder here and just copy XAudio 2 and copy all of the files, all the header files that it depends on from there, and then go into and just copy it or just paste it into a folder in here. Like we have dxflib, we'd have another folder for XAudio 2. And if I did that, then it wouldn't need to use this absolute path. I'm sure there's probably something against redistributing SDK files, though. There's probably some bullshit. I don't know. But anyways, I'm still thinking about doing that because I don't like this idea. This isn't good. It's not good to use absolute paths to files on your disk in your source code. It's dumb bullshit, and I don't like it. Next, moving on. I'm done with this topic. Fucking hate it. Where's my changes? Fuck, I don't want change, I want branches. Sound. We'll go view history. Okay. So the next thing that I did, let's just take a look at, there we go, Win8. Okay, that's done. Next thing, I use smart pointers. You've seen me use smart pointers before. I've used unique pointer. Now, the one I'm talking about is one specified by Microsoft, and it's a smart pointer for use with COM objects. Because as you know, COM objects require you to call release on them. So they don't have a destructor. They're not actual C++ objects in that sense. If you have a pointer to a COM object, you got to call the release function, and that will decrement the reference count. And when it reaches 0, then the COM object will be, destroyed. So you can't use a standard smart pointer, because a standard smart pointer doesn't call release, it calls the destructor. So what do you do? Well, Windows has given us something nice recently, Microsoft. There's something called the WRL, which is like the Windows runtime library, and it's got a bunch of dumb bullshit. But anyways, what I'm interested in here is the smart pointer that it gives us. It's called Microsoft COM pointer, and it's a templated pointer, so you can template it for any kind of COM interface type. So this one we change from an XAudio 2 pointer to a COM pointer templated to XAudio 2, and mostly it just works the same. Like let's see here, where's some code? There's not really much else here. Let's look here. Let's take a little looky here. Yeah, nothing changes here. You can still, the smart pointer, it overrides the address of operator. So you can just call address of, and you'll get the address of the managed pointer, and that'll allow you to pass that to XAudio to create to fill it up with an address. So mostly it works the same, but now I don't need to do all this bullshit, because this is going to be destroyed automatically. And another thing that I've done here is I've created a COM manager COM manager class. And this, what it does is its constructor initializes COM and its destructor uninitializes COM. Wait, I got that backwards. Initialize and uninitialize. And this allows us to do everything without having a destructor, because it allows us to make sure that COM is uninitialized last. You don't want to do anything, you don't want to call COM functions when COM has already been uninitialized. So, what we do here is shit gets uninitialized in the destructor, in the automatic destructor. I don't know what you call it, but it gets destroyed in the opposite order that it was created. So this is created first, which is good. It gives us a COM, sets up COM before we do any other bullshit. And it's destroyed last, so it uninitializes COM after we're done with all the COM bullshit. And this thing will come second, the engine comes second, and then the channels come. And in reverse order, all the channels are destroyed, all their contents are destroyed. And then, where is it? Mastering voice isn't a COM object. It doesn't. You don't have to do anything with that. And then the COM pointer is released. Release is called because it's a smart pointer. And finally, COM is uninitialized. And it just makes your life nicer, easier, less chance of you fucking up your bullshit. No need for any more destructors. Good stuff. Very sexy C++. I like smart pointers. I like them a lot. This change was nothing, just bullshit. I had originally specified that CB size has to be this, but it's actually just You don't have to worry about this member of the format. It's not important. It's not an important member of the wave format. I'm not exactly sure what it does. I think it's like a size of the header for like extended information or something. I don't know. Doesn't matter. We don't have to look at it. We don't have to compare it to all the files we load to see if they match because it's not important. Next is, I made a kind of mistake when I was writing this bullshit. That's not it. Where is it? Here it is. So here in play sound, we check to see if there are any idle channel pointers. And if so, we move one of them into the active channel pointers, and then we call play on the one we just moved. That's fine, except that although we move the contents of the smart pointer, the unique pointer, we don't actually pop the unique pointer from idle channel pointers. So the empty unique pointer remains in here. And then if you try to play another audio file, it's going to try to access that empty unique pointer and it's going to puke. So you've got to make sure that after you've moved the pointer contents, you actually delete the unique pointer container from the vector of idle channels. That's what we do here. Just make sure we pop it. Now here I added a little comment that I don't trust this code. The reason I did that, I talked about this in the last episode, but the reason is because this voice callback, this function, is called not by our main thread, but by the XAudio thread. I think last episode, I said that XAudio has one thread for every voice. That was wrong. That was a mistake. It only has one worker thread. But still, that worker thread is what is going to call this on buffer end. And it's not going to be the same thing as our main thread. So because we're accessing stuff like we call channel, we call p sound. So this is a sound object. We call remove channel on a sound object. And we call deactivate channel on our sound system. So we're accessing stuff that our main thread is also accessing and also writing to. And if you have two threads that write to a single memory location at the same time, that's bad. That's called a race condition. Two threads writing to the same thing at the same time is bad. Multiple threads, you can have any number of threads that read from the same memory location. That's okay. That's fine. We like that. That's the good stuff. So you've got a memory location, any number of threads reading. That's okay. That's fine. If you have one thread that writes and other threads that are reading, this is okay. Maybe it's okay, but it depends. Because sometimes this thread, its writing, might not become visible to the other threads because of the way that memory access works. Remember, you've got a CPU, you've got multiple cores. These cores have cache memory inside them. So this is cache. And so when it does a write, it first writes to the cache. That write might not immediately go into the larger cache or into the larger memory. So when it's working with memory, it might only be reflected in here. The other CPUs, when they read the memory or when they refer to their own cache, they won't see the changes done by this CPU over here. And that can cause problems. So this situation of one thread writing at the same time as other threads are reading is maybe okay, but maybe can cause problems. Now, the bad touch is when you have multiple threads trying to write to the same memory at the same time. They're all trying to change that memory. Because you get a race condition, you get a situation where you don't know which one's change is actually reflected. Which one comes first, the chicken or the egg? It's like, let me give you an example. Maybe it's better if I gave an example on writing surface. Now, let's say you've got like a vector. I think I missed a letter in there somewhere. And you've got two threads. One thread is going to pop, and the other thread is going to, or let's say this thread is going to, I'm not sure what I'm doing now. Let's say it's not a vector. I'm getting ahead of myself. Let's say it's a list. A list is it's got a bunch of pointers to, it's a linked list of pointers, right? Now this one, list. Now we're going to pop from the list. This one is simultaneously going to try to access the member that's being popped. So this one's going to try to write. It's going to try to change the member. Now what happens? This one starts writing to this memory. At the same time, this one pops. It deletes the memory. This one's trying to write to memory that's now deleted. Now you're fucking up your shit. That's just one example. It might not even be a very good example, but it gives you the idea of why you don't want to have multiple threads accessing the same memory at the same time. So this one calls remove channel on sound, and it calls deactivate channel on sound system. And whereas remove channel accesses the active channel pointers. Right. This accesses this vector in here. But add channel also accesses it. And add channel can be called from our main, our main thread. And it's the same thing in the system. There's memory that's being shared between threads, and it's bad because we're not doing anything about worrying about what happens if one tries to erase memory when the other one's trying to access it or other bullshit like that. This is a problem of our times. So that's why I wrote this little message in here. Basically just a memo to myself to talk about this bullshit when I go over the code. Now, we're going to go into more detail about how to fix that later, but just for now, know that multiple threads writing to the same memory, bad situation almost always. There's a situation where it's not bad. It's called atomic operations, but we're not going to talk about that right now. We're not going to talk about that today. We'll talk about that another day. Today, we're going to move on. What's the next thing that Chili did? So I fixed this. Now bullshit doesn't happen. Now I created a version here. I actually created I don't know why I created this actually. But anyways, I created a commit here to show my testing. I made a test, and the test was to try to get the system to get to puke on that situation I told you, like the race condition, where the callback thread, the XAudio thread and the main thread try to access the memory at the same time, and they crash the program. And I made it crash. It takes a while though. You have to run it for a few minutes and then it will generally crash. You got to realize that these two threads are running at very fast speed and they're completing their operations very quickly. So it's a very small chance that they both happen to be accessing the same spot in memory at the exact same time in such a way to cause a crash. So, but if you run the program long enough, it will crash spontaneously. You don't have to do anything. It just crashes suddenly. So what I did was I made it load this is a shorter file. Buttspin is a long one. Cartoon is a short one. Now, one problem is this isn't included in the project. If you look in the media, I didn't include this sound. Wow, why is this included? This isn't, I'm not even there yet. Oh, because I didn't change my, oh shit. Okay, well, let me change my branch. So I'll just show you what's happening here. Show you what's good, as they say. Now, branches. Okay, I called it threading. It's going to be down here. All right, so short. Here you go. Here you see that. Wait, cartoon.wave is included in here. It's included in here, but it's not in I'm pretty sure it's not in the folder. Let's just look. Cartoon. No, it's not in here. So for some reason, I don't know why, it's not on GitHub. Buttspin is on GitHub, I think. But Cartoon is not on GitHub. So what happens is, let me just look at the history for a second here. Yeah. What happens is when you try to load Cartoon, it's just going to crash. So what you have to do is you have to get your own file in here, and then you just got to copy your own file and you change this name to the name of that file. And it'll work. I recommend a short file. This test, it launches 8 sounds every frame. And if you see here, the number of channels, the maximum number of channels has gone up to 256. You see, back when I created this code, I figured that there was one thread for every sound being played. For every active sound, there would be one thread, which is wrong, by the way. But so by launching a bunch of sounds, I figured I'd have a much better chance of causing the program to crash, so that I could, diagnose the problem, see exactly where the conflict happens, maybe show that in the video. But it's not quite the way it works. There are not, 256 threads running. That's insane. That is kind of stupid, now that I think about it. But anyways, I think increasing the number of sounds does increase the amount of work that the worker thread is doing, and therefore increase the chance that it happens to access memory at the same time as the main thread is. But anyways, that's not important. The important thing is that you can you can prove that this current system of concurrent access to variables is not good. It will cause the program to crash for no particular reason. Well, at least from the user's viewpoint, it'll just crash for no reason. So yeah. Now, the other problem that I encountered while doing this was, let me just show you. I got to start the task manager, and then I've got to move an audio file into the folder here. So let me just do that. Because if I try to, let me show you. If I try to run this as is, get rid of that, build. It should build fine, but when I run it, it will crash. Yep, because it has not found can't find the file that we're looking for, the audio file. So what we want to do is we will open the folder and we'll move this wave file into here, -2. Copy that. You can, if you're following along, if you want to maybe see how the program crashes for yourself, you can just put your own file into here. Build that bullshit. We'll start without debugging. Oh, that sounds horrible. Oh, it crashed. That's interesting. It normally doesn't crash for a while. Here it crashed right away. But that's not the thing I wanted to show. That's not the thing I wanted to show. What I wanted to show was what happened if you close it. Look in here. Engine.32, it's still running. It's eating about 13% of my CPU, which is all of a single thread. There's a single thread that's just burning away for no good reason. Why? Why don't you close? This is the problem that plagued me. Now, I figured out that the place where it was hanging, let me just go, where is sound.h? Here it is. The place where it was hanging, where is it? Because obviously it's when you close the program, so it's got to be in some kind of like a destructor type situation. It's right here. So here, for every channel, we call stop. We want to make sure all the channels are stopping. And then we wait for the XAudio 2 worker thread to get the stop message, to stop the channel, to call the callback for stop, for on buffer end, so that the active channel pointers can be removed from the from this vector. Because what will happen is the callback function will call remove channel, and it will remove all the channels from this vector. And when all the channels are removed, then we know that all the channels are stopped. They're not trying to access this data anymore, and then we can finish our destructor and destroy this data. That's the idea. But the program just gets into an infinite loop here, and it never stops. It never gets out of this. It just hangs, and because it's a while loop, it runs like it just eats up all of one core, basically, or all of one hyperthreading core, if you want to say. So that's a problem, and I didn't know why it was the problem. I will tell you later. Right now, it's not doesn't fit into our whole history thing here. So, what is next on the menu? Let's change our branch. So we're going to go back to just the standard sound. Oh, there are uncommitted changes, right? Because I changed that file name. So let's go to changes. Undo that. That will allow us to go to branches, change back to sound. We're in sound, we view history. Where are we now? So here's where we're at. We've still got a while to go, but some of it will go through very quickly, hopefully. All right, so next thing I did, what did I do? So I added the file that I forgot to add last time. I added it in here. So here's the cartoon file, cartoon.wave. And the other thing I did was I started, because I didn't know why that hanging problem was occurring. So I figured, okay, I'm going to do this anyways, so let's put in all of the guards to prevent the memory access, the concurrent memory access. So this is how you protect memory that's being accessed by multiple threads at the same time. You use what's called a mutex. We'll get on to that in a second. The other thing I did was in this while active channel pointers size greater than 0 thing, I added a sleep function that causes the thread to sleep for 1 millisecond and then test. And if you do this, the problem goes away. It doesn't make sense. Because, I mean, whether you sleep for 1 millisecond or whether you run this thread, the other thread should be able to remove all of the elements of this vector. And once that happens, the next time you test it, it'll be equal to 0 and it will exit this while loop. But for some reason, adding this sleep in here fixes the problem. I know the reason, but I'm not going to tell you yet. You gotta add a little suspense to this. You gotta add a little spice to life. So, anyways, that will just keep this in the back of your mind. Why does this sleep 1 work while the standard spinning loop here didn't work? We're not going to worry about that right now. What we're going to worry about is what the fuck is a lock guard and what the fuck is a mutex. So the thing about a mutex is mutexes have, where's my diagrams? Where's my stories? Here we go. Mutexes have, well, they have a bunch of things, but in general, every mutex is at least going to have a lock function and an unlock function. And what happens is the first thread that calls lock is going to pass through. Lock is going to return almost immediately, but it's going to set. Mutex also has a data member called locked, and it's going to set that to false. No, wait. It's normally set to false. It's going to set that to true. And then the next thread that tries to access lock, it's going to block. It's not going to be able to continue processing until this thread calls unlock, when it calls unlock, I shouldn't want to put an X there. It gives the wrong message. When this thread calls unlock, this is going to be set to false. And now this one can enter. And when it enters, it's going to be set to true again until it unlocks, and then it'll be set to false. So it keeps a kind of gatekeeper variable. And the first thread who tries to lock the mutex will pass through, but every other thread will block until the first one unlocks, and then one of these threads, only one, will unblock. And when this one unlocks, then the last one will unblock, and so forth. Now, the beauty of the mutex, and the thing that makes it special, is that if you have two threads, think about how you would implement this if you're trying to implement it just with standard C code. If you had two threads that access lock at the same time, what does lock do? Well, lock is going to check to see locked is locked equal to true. And if it is locked, it's going to block the function. It's going to say, stop working, just spin here and wait until locked is equal to false. But if locked is equal to false, as it is in the initial situation, it's going to let the thread pass. Now, what happens is if you have two threads that simultaneously access, they're going to simultaneously check locked, and they're both going to see locked is false, and they're both going to pass. But that's with a normal implementation. But with the mutex, only one will be able to pass. They can't both pass at the same time. That's the beauty of the mutex. Even if two separate threads simultaneously access it at the same time, only one will be able to lock it. The other one will be blocked. So and what that gives you is it gives you mutual exclusion, mutex. Isn't that beautiful? So only one thread enters and the other ones are excluded. Now the other piece of this puzzle is our friend here, lockguard. Now what this does is this is just a very simple class, and what it does is in its constructor, it takes a mutex and it locks that mutex. And in its destructor, it unlocks the mutex. So it automatically manages the locking and the unlocking for you. Because imagine what would happen if you locked a mutex, but you forgot to unlock it when you were done, accessing the shared memory. Because what you do in general is you lock the mutex, you access the shared memory, and then you unlock it to tell, the other threads that they're free to access. But what happens if you lock the mutex, access the memory, and forget to unlock it? All those other threads now are blocked for all time. They just hang, and your program will probably just crash. So one thing that the lockguard gives you is it gives you automatic locking and unlocking of a mutex. Once you leave the scope in which it was created, it'll automatically unlock that mutex. Now, that is good, but the reason why it's almost imperative that you should use a lockguard is imagine a situation where you call some functions in here that can throw an exception, and one of them throws an exception that will automatically jump out of this scope and hit the exception handler. Now, what happens if you just standard lock the mutex and then you hit an exception? You leave, you handle that exception, your computer, maybe your program can recover, it keeps running, but that mutex stays locked forever. And so even though your program has managed to recover from the exception, it's still going to freeze up. Now, if you use a lockguard and you hit an exception, leaving the exception triggers the lockguard's destructor, unlocks the mutex for you automatically, everyone's happy. That's the reason, that's one of the main reasons why smart pointers are being pushed so hard in C++, is because especially they allow exceptions to not fuck up your stees. Exceptions and smart pointers go hand in hand, but in general, smart pointers are just a good idea because they protect the programmer from themselves. So I recommend them whenever you can, which is almost always, I think. But anyways, so that is the mutex. So here, with this mutex, I basically have two mutexes. One mutex is inside of sound, and it protects the shared memory of the sound object. Specifically this, the active channel pointers vector. There's another mutex in here. This is in this sound system, I believe. And it protects the shared memory, specifically these vectors here. So these are affected both by the main thread and by the XAudio 2 thread. And yeah, so in any situation, any function that's accessing that shared memory, I make sure that I put a lock guard in front here. And that will enter the critical section. You call the part of the code where you don't want multiple threads to be in at the same time. You call that a critical section. So you enter the critical section, and once you leave this this scope, it'll unlock the mutex. Everyone's happy. In here, I just get rid of this thing. I added this when I didn't know what I was doing. I was just like grasping at straws, trying to figure out why my program wasn't quitting on its own. So I added this in here. Don't worry about it. Doesn't make sense. And that's about it, I believe. Yeah, that's it for this one. Now let's see if I've forgotten anything. No, I don't think I have. But yeah, by making this change, I've noticed that no more spontaneous crashes. So by protecting the shared memory, the program doesn't just crash. You can leave it running for hours. It won't crash on its own. But the one thing that has still plagued me at this point in the development is, why does adding sleep here fix this problem of the program not closing properly even after I click the X button? So we'll see that in the next part. Let us continue on. So this was this. Sync implemented, still hanging in release build. What did I do here? What is sync implemented? So here we play the sound. What do we do here? Here I get rid of this because, like I said before, it didn't make any sense. I get rid of this comment. Oh, I call stop. This is a small thing, but when you reach the end of a voice or the end of a buffer and the end of the stream, that doesn't automatically stop the voice from playing. So if you were to pass it another buffer, it would immediately start consuming that buffer, I believe. So here just explicitly stops the voice when it reaches the end of the buffer. Because I found that it wasn't working. My system was assuming that the voices were stopped, but they weren't actually being stopped. Here... Oh, I just made a note here that I don't need to use a mutex to protect this data in here. I think maybe this add channel, because the thread's not running yet. So I didn't need to protect some kind of data here. It's not important. What is important is... Oh yeah, this update, I didn't do much of anything in here. I reverted back to this while loop. And I changed, because play sound is actually, there is a macro or maybe another function from Windows that's also play sound, and it was colliding, and it compiled fine, but in my syntax highlighting, it was making this one a different color, and I didn't like it. So I changed that. I changed it here. I just changed a bunch of names of some bullshit. Nothing big. So we're not going to worry about it. But yeah, stuff was changed. let's move on. All right. So here's where I figured out why this was causing my program to hang when I tried to close it. And the reason why is the optimizer, the compiler, because I didn't say this, but the hanging thing only happened in release build. It didn't happen in debug. And the reason for that, I mean, that is the thing that you hate the most, when your bug doesn't happen in debug build and therefore you cannot debug it. That shit pisses me off real hard. But anyways, so the problem was that the compiler was optimizing this memory access. So when it calls active channel pointers.size, it checks a variable in size of vectors, the number of, the size variable. And what it does is it reads that. Now, because this is a while loop, let me just show you. Not this one, but this one. Because this is a while loop with no body, it doesn't do anything except for check. The compiler said, okay, you're reading that memory, but you're not doing anything afterwards, so that memory can't change. So we're not going to read it every iteration. We're only going to read it once, and then we're just going to compare that red value to 0 every single time. And in doing so, because it never reads the value, it can never detect any changes, and so it just enters an infinite loop. Now, I mean, that assumption is fine if you're assuming that only one thread is accessing memory at one time. But in the actual case, this statement is predicated on the assumption that another thread is going to change our container, and therefore at some point in time size is going to change and signal that we can exit the while loop. So what we want to do is we want to tell the compiler, don't make that optimization. You can't assume that that memory is not going to be changed because another thread, another processor might change that memory. And the way you do that is you do an atomic thread fence memory order consume. Now these fences, there's a whole bunch of different kinds of them, and they're all there for a bunch of different cases. Remember when I was talking just a little bit about how you got different processors accessing memory, and because they have, I must have deleted that diagram, but because they have cache, right? They might write to memory, and that write might enter their personal L2 cache or L1 cache, but it won't be seen in the caches of the other processors. So in order to make sure that memory changes in one processor's cache memory appear in another's, you would have to use these kinds of fences, thread fences. And this is a very simple thread fence. It doesn't have anything to do with, cache coherency, which is the thing of different caches having different values. This one has to do with just optimizing memory accesses. So this one just tells the compiler, don't optimize, make sure that you read that memory every single time, because it could change. All right, so that solved my problem, and it made me a happy pappy. Let us continue. In this one, all I did was, because even though that code works, it is the proper way to do that would be to use a mutex and to lock the mutex so that both different threads couldn't access the vector at the same time. So I redid it with the lock guard just to make sure. I could have done that from the beginning, but I knew that although this code isn't preferred, I knew that the while loop should work, and the fact that it wasn't working was bugging the shit out of me. So until I could get it to work, I was not going to use the proper way. But once I got it to work, then I was like, okay, let's do it the right way. Let's use a mutex. And that's what it works. That's how it does. That's how we do. Exception message, file does not exist. Okay. So the next thing is the thing that I was telling you about before that I wasn't going to talk about, and that was exceptions. So this, I've actually created a branch point for this, and I'm going to switch to it so that I can build and show you what happens. So let's do that right now. Branches, the branch point is exception ng. So let's go to exception ng. And what I did here, well, let's just view history. And what did I do? Changed, added exception in here, try. All right, so what I did in Windows was I added a try catch block around, our main message loop and our main game processing loop, the thing that calls the game process. And so that's to catch any exceptions that are thrown from our game. And then this just prints them out in a message box. And in here, in game, I intentionally misspelled the name of a file so that it would throw an exception. And then I build. And I'm assuming that I was going to get an exception saying something about file access. But when you do it, you get an exception, STD exception, sound system error, sound system file error, bad 4cc. So it's telling us we're getting a bad 4cc code. But that's weird because the file doesn't actually exist. So I was like, that's kind of weird. Why is it doing that? And the answer is, let's go to branches and let's go to exception yes, I believe is the one. And we're going to look at the history of exception yes. So the reason why is because by default, streams, IF stream, doesn't throw exceptions. It has the ability to throw exceptions, but it does not throw exceptions by default. Because, if it did that, then everyone would have to catch exceptions, or otherwise their program would just crash as soon as something bad happened. So rather than forcing everyone to use exceptions like you have in Java, well, at least back in the day, I don't know about today, what it does is it disables the exceptions, but you can enable them. And that's what I do here. I create another scope for the file. Well, no, that's not true because I had the scope already created here too. But I create the file and then I enable the exceptions. I enable exceptions on fail bit and I enable exceptions on bad bit because they seem like the ones that I would be interested in. Then I try to open the file and I catch a standard exception. And when I catch it, what I do is I take the text from that exception and I add to it error opening file, and then I wrap that in a sound system file error exception and I rethrow the exception. So here I'm intercepting a standard exception and I'm taking its message, wrapping it in a sound system file error exception, and then rethrowing it. And down here, what I've done is before, that's weird. If B filled data. Right. So down here, what I'm doing is I'm trying all of this. Right. So I've wrapped basically everything with a big try. And I'm catching all the exceptions. And if it is a sound system error, any kind of sound system error, I just rethrow it as is. But if it's a standard exception, what I do is I wrap it like before. I wrap it in a sound system file error and throw it. Because if I throw a standard exception, it doesn't tell me much about where it came from. If I wrap it with the sound system, that will enable the handler to know, oh, this exception came from something in the sound system. It's not just a random STD exception. This is an exception that happened somewhere in the sound system. So just giving more information. The reason why I do that is because, for example, let me see here. It doesn't make that much sense. Like this file.read this could throw an exception ostensibly. And if it throws an exception, what I want to do is catch it here and then rewrap it as a file error exception with the contents of the original exception contained therein. So that's all the dumb bullshit I do with exceptions here. And this works fine. If I, let's see, if I build and then run, here we go, std exception, sound system error, sound system file error, error opening file, iOS fail bit, set iOS stream error. So it's not the best. I think I could do better. What I would do, I didn't do it here, but what I should have done is probably, if I catch an exception for opening the file, I should add in here somewhere the file name into here so that you can read, okay, when you get the exception, you'll see error opening file, but.png or whatever, I don't know. But I didn't do that, so it's not the best error message, but it's not the worst. It gives you a decent clue about what went wrong. It's better than nothing, right? So that's what's happening with exceptions right now in our situation. Let us continue. Let's go back to branches. Let's go back to sound. Let's go back to history. See where we're at. So exceptions. Next thing I did, very simple. Compared to the other stuff, this is super simple. Added the collision sound to the ship. And what this did, you add the collision sound of just a sound object in here. You call play on that when you get the rebound message. And that's about it. I mean, there's not much else to it. I removed this test sound from here and added a new wave. Whoa, shit. Added a new wave file for the collision. That is about it. Let us continue. Now, one problem I was having was the sound there would be a popping sound at the very end of the sound. And anytime you played a sound, at the very end, you'd hear a pop, an audible click. It was bugging the fuck out of me. I tried everything. I was like, what the fuck is this bullshit? And then I realized it was just me being a dumb asshole because, so what I do, like I said in the other episode, I may have actually mentioned this, but what I do is I load the file, I check the 4cc code, then I read in the file size, and I use the file size to load the entire file into memory. And then from that point on, I just access it as an array in memory. But the problem is I use the file size to load the entire file into memory. But the file size is not the size of the entire file. It's the size of the file after the data for the file size. So it doesn't include the 4 bytes for the 4cc, and it doesn't include the 4 bytes for the file size. So it is exactly 8 bytes smaller than the actual file size. And so I was missing the last 8 bytes of the file, and I was missing some samples in there that caused it to pop at the end, because it was going from some value directly to 0. So it created a pop sound. It wasn't good. So what I'd have to do here is I read in the file size, then I add 8, and then I do, the other shit. I also increased the minimum file size. It has to be at least 44 bytes now. Because that seemed, I don't know, it seems better for some reason. I guess that's the minimum size you could have for a WAV file with any kind of data in it. Anyways, you're probably going to need a file bigger than 44 to get any kind of useful sound, but I decided this was the bare minimum. All right, so that was me fixing some dumb bullshit in my loader. Yeah, it's fine. I'm not going to go into this. Oh, I guess I could go into this. I don't know if I'm actually recording if I'm actually recording the system audio. So I don't know if you can hear the game when it's playing, but this is mgun. Now let's go into, where is it? Shit, here it is. Branches. We'll go to mgun. And we'll build this mother. Yeah, and we'll see what it sounds like. Oh, this is off the screen. So we'll go new game. Well, let's see if you can actually hear it. I don't think you can hear that. Let me just point this microphone at the speaker. So I don't know if you could hear that, but you can always, try it at home if you really want. Sound effects are coming out fine, but it's the same sound every single time. It's G, 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 G. It's really fucking annoying when that bullshit happens, right? It's the kind of machine gunning effect of a sound effect. And it's not a good thing, because in real life, generally, if you do the same action, you'll get about the same sound, but there'll be small variations. Not every footfall sounds the same, right? So, the way to fix this, there's a bunch of different things you can do. This is, by the way, this is the, I haven't been following the docket very well. But for your information, we finished this, we talked about concurrency, we talked about Mutex, we talked about the thread fence, talked about exception handling and rethrowing, and now we are in the sound effect system. This is the quote-unquote interesting part of the lecture, in case you were following along or not. Anyways, let us change our branch back to sound. We're going to close all documents. We're going to open the history on sound. All right, so where are we at? We're at machine gun. So machine gun, bad. It sounds stupid. It sounds dumb. One way to fix that is to slightly modulate the frequency of playback of a single sound effect. So in order to do that, we have to support frequency modulation in our sound system here. So what we're going to do, what I've done here, is I've changed some of the functions here. Now they take a frequency argument, and in XAudio, you modulate the frequency based on floating point 1. So 1 means playback at the standard frequency. Less than 1, playback at a lower frequency. More than 1, playback at a higher frequency. So 2 obviously is going to double the frequency. It's going to make the pitch twice as high. 1 octave. Twice as high pitch equals 1 octave higher. So here we just change these functions so that they can take a frequency argument. Play sound buffer. And up here, play sound buffer. Takes a frequency in here. I think I went a little overboard in the default 1 here. I don't have to do it everywhere, but anyways. Now in the sound, this is where the actual frequency modulation happens. All you do is before you start the sound, you set the frequency ratio. And there you go. Now you'll be able to play a sound at a different frequency than the one it was recorded at. Different pitch, I should say. And this code here just lets you... I just use the mouse, and you can play a sound by clicking, and you use the wheel up, wheel down to change the frequency modulation factor. I'm not going to go into it. Now what I do with that is I create a new class called sound effect. And what sound effect does is it encapsulates a sound, and it also encapsulates some random number generation bullshit to randomly create minor variations in the frequency. So you create a sound effect, you pass it the name of the file, you pass it the amount of deviation of the frequency, and you pass it a seed value for the random number generator. And then the frequency distribution here, this is a distribution. It takes a random number and it will redistribute it into a certain range. This is a normal distribution. Normal distribution looks like, I think it's also called a bell curve. It looks something like this. And so this would be the most common value. And as you get farther away from the center value, which is 1.0 f, you get less probability of that value being output. So what happens is that if you have a high deviation, your bell curve is going to look something maybe like this. If you have a very low deviation, your bell curve might look something like this. So you can tailor how much you want it to deviate, but it generally is going to cluster around, the natural center, the actual frequency of that sound. So you will get, very rarely will you get a frequency that is much higher or much lower. Generally, you'll get very close to the frequency of the original sound, which is what you want. You want a natural distribution of frequencies used. So that's how normal distribution works. You can template it to different types. I template it to float. You pass it an RNG, a generator, and it will poop out a random number which has been distributed over, the normal distribution. So now in ship, we include sound effect. We create, instead of including a sound, we include a sound effect. And we initialize it with deviation of 0.037. That's about 3.7% standard deviation. Or I don't even know if that's standard deviation, but that's the amount of deviation for that distribution. And we use random device to generate a seed that the random number generator will then use. Random device just takes a whole bunch of system variables. It's kind of like generating a seed based on time, only it's way better than time because it uses a whole bunch of different system variables together to create some kind of pretty much random number. And that will use to seed the MT1 whatever, MT19937 generator. That's generally how I do random number generation. We get rid of the test file from here, and Bob's your uncle. I was going to play this, but as it seems that my setup right now isn't recording system audio, you won't be able to hear the ship. But take my word for it, now it sounds better. It sounds more natural because the frequencies are being varied to a certain degree. The next thing I do is I create a matrix of sounds. So instead of having one single sound effect, I have a vector of sounds, and I choose which one of them to play. They're all the same, around the same sound. These sounds are, by the way, lightsaber clash sounds, right? The sound of one lightsaber hitting another. And I've taken a few of them. I've taken 3 of them. They sound fairly similar, but they're quite different. I create a matrix of sound effects. And I create another distribution. This time it's a uniform distribution because I want every value to have an identical probability of being chosen. And it's not, this one is going to be an integer distribution because I don't want a whole range, a whole spectrum of values. I just want discrete integers, which are going to be used to index into our vector of sounds, our sound matrix, if you like. So now loading is a little bit different because I've got to create a distribution which is equal to the amount of wave files. Oh, I use an initializer list in here so that I can pass in a variable amount of strings for the files. I take the size of that list to be the amount of files that are going to be, or amount of sounds that are going to be in the matrix. And so my sound distribution is going to generate values between 0 and number of files minus 1. So it's going to generate indexes. And here I go through each of the strings in the initializer list, and for each one I load the sound into the vector of sounds. And in my playback now, I do the frequency distribution, but I also do another distribution here for random number for the index. So I play a random sound from among the, in this case, 3 sounds that I load in. So the way that works is here, now I create collision sound, and I use this initializer list bullshit in here with the curly braces to pass in 3 file names, and the other stuff is the same. And so now we get a bunch of different sounds. Let's see how that works. I can move my microphone again, I guess. Let's go to the branches, and let's go to matrix, SFX matrix. We'll build that and start. Move it up here a little bit. Oh, error opening file. Okay, well, it looks like I did not include the file. Yeah, I've only got collision 1 in here. So, dumb me, I didn't include the proper file. Oh well, let's move on. We'll go to sound. We'll go to view history. All right, so the next thing is the volume modulation. So here, what I do, here I have added the collision sounds, so I can actually show you how it works. But here, what I do a bunch of stuff. I add support for changing the volume of the playback. So now, instead of just passing in frequency modulation when you call play, you can also pass in a volume value. And what else? I've gotten rid of the what do you call it? The default values in here. For reasons. And the way it works is, I'm going to sound.cpp, just like the other one with set frequency ratio, you set volume. And I believe volume also, 1 is just no change, less than 1 is damping, greater than 1 is amplification. Now in the ship, for rebound here, what I'm doing here is I'm basically calculating the speed of the ship with respect to the surface that it is colliding with. So with like the normal of the velocity of the ship in the direction, or the velocity of ship in the direction of the normal of the surface with which it collides. Because I mean, if your ship is moving, I talked about this when I was doing the shield, but if your ship is moving almost parallel, like where's my I'm not getting. There we go. If your ship is moving like this, almost parallel, and just sort of glancing off the side, obviously you don't want that to make as big a sound as if you're moving directly into and crashing directly into the wall. So we take the velocity vector, the component in the direction of the surface that we're colliding with. That's all that this bullshit is doing in here. It's just calculating that, and then calculating a value for the volume based on what that velocity is. So basically a velocity of 800 gives us max volume. And the minimum that the volume can be reduced is 0.1 of its original value. And the rest is just some math bullshit. I'm not going to talk too much about it. It's just it's your standard linear interpolation on the velocity, basically, with some min-maxing so that you don't get value, like it doesn't go down to 0. The minimum it can get down to is 0.1, right? And then you play the sound based with the volume here. So now that we have these collision sound effects, we should be able, fingers crossed, to go, where is this one? Sound effects volume, build it, and we should be able to play this mother. This video has gone on much longer than I had hoped it would, but I guess it makes sense, talking about a lot of different bullshit, talking about threading bullshit, talking about API bullshit. That's a lot of bullshit. All right. I don't know if you heard that, but wait. All right, so that's kind of what it sounds like if that came through on the microphone, which I'm not really sure if it did, but hopefully it did. If anyways, you can always try this out on your own by just, looking at the final product. You don't have to create these branches down here. So that is the volume modulation. The last thing I did in this thing, wow, I'm just losing my ability to speak English completely here. The last change I made in this branch, there we go, is I also updated direct input to use COM pointers instead of using standard pointers. So here, the I direct input, we now use a COM pointer, a smart pointer to access that. So that makes, the device pointer also using the COM pointer, and that makes our destructors a little more simple. And it also, the other thing I did was that thing I talked about a while back, where it was I make this into a while loop so that it keeps removing events until the size is less than the max or equal to the maximum size. So I finally fixed that problem. Now the last thing I did here, not a big deal. I just removed, I don't know why, but I removed color from inside of the triangle strip. So it's not, the triangle strip object now does not keep track of the color. That is just something that you pass in when you call get drawable. And because I don't know, it didn't seem like something that was part of the triangle strip. Triangle strip is all about geometry, and the color or whatever that comes from whatever is using the triangle strip. So that's that. That's the whole thing that I wanted to talk about. Holy shit, how many minutes are we at? 1 hour and 18 minutes. Maybe I can cut some out. Maybe I can't, but we did it. We did it, Reddit. We covered all this dumb bullshit. So yeah, next episode, I think, okay, don't quote me on this, but I think the next one is going to be starting on the bloom effect system. And there's going to be a little bit of math in there and all sorts of good bullshit, and it looks fucking sweet if I do say so myself. But that's it for the audio bullshit for today. So I hope you enjoyed the video. Hope you got something out of it. If you did, please click the like button. It helps a lot. And I will see you next time. Goodbye.